Okay, so let's continue on and look at some one-shot operations and just a simple add function to start off. Okay, so where we left off with the timers running and my power on output Q0.0 toggling on and off. So let's say we want to count how many times this happens. And for the sake of arguments, I'm not going to use a counter. I want to build a counter. So let me take this offline for a second. So let's grab add, and we're going to drag it down into here and put it normally open to start. And I'm going to use my power on, press Control key, bring this down, drop it, so I can add that in. And I've already created a variable called time count. So I'm going to use this as my variable, and that's a global variable, and you'll see what I mean by that in a second. I want to add 1 to that, and I'm just going to go ahead and put it right back in the same variable that it came from, time count. And the reason I said it was a global variable, as you can see, it comes up here as MD0. So that's a double data word in the M area starting at 0. So if we go ahead and I always save before I download, just force of habit. Download in, monitor. Okay, so now every time power on turns on, we get, oh, look at that. It's counting like crazy. What's happening here is every time this add function sees enable on, it takes whatever's in time count, adds 1, and puts it back into time count. But it does that every scan. It doesn't just do that the first time it sees power on turn on. It'll do this every scan of the function. So the reason I wanted to throw that in there is just give you a caution that some of these features are scan dependent. That means every time that the scan comes around, if this is true, it will perform this function. Which is fine if you're just doing a simple add function, but if you're doing some recursive adding or iterative processing, we have to be very, very careful how we use that function. So how do we fix that? Let's take a look. Let's go offline here for a sec. How about I just create this as a one-shot? So I go over here to bit operations and see what I have available. And I have this P. It looks like a normally open contact with a P in it. And then if I mouse over it, it says scan operand for positive signal edge. So that's exactly what I want. Now since I already have power on normally open, I can double click on this icon, pull down, and actually change this to P for positive edge trigger. Now notice it's asking me for another sort of tag or something down here. Well, in order for this one shot to work, it has to have another memory allocation or another bit associated with it so it can remember what state it was in last time. So I just happened to create a memory area, M10.0, and I'm going to use that as my one-shot temporary bit. Okay, so in order to use this function, whatever I want to monitor, Q0.0 is on top, and then my temporary bit on the bottom. And this temporary bit is unique to this one-shot. I cannot use this temporary bit in other one-shots in the same program because it's used to remember the state that this instruction was in last time. So you can't constantly reset and set it using other instructions. So it must be unique to this address. So let's see what happens now. Let's download this. Save project, download. Now notice it's already counted up to 151,000. So maybe we should just reset that back to 0. So let's go to our watch table. And notice I've already set it up in my watch table here. Modify was playing with it before, so my modify value is 0. I've turned my modification enable on. Let's go here and trigger it. You notice it's already counting. 4, 5, 6. So every time my timer turns on, or turns that output on, I count. I cannot see this rung turn on is too fast for the scan. It's actually turning on only for one scan, and I should say it's too fast for the monitor program to see this. So you can't see it working. You can just, you know it's working because we're counting up by 1. Okay, that's one style of Oneshot. Let me show you another style. If I go down over here, again in my contact area under, again remember I am, bit logic operations, have another possibility here. It says PTrick. So I'm just going to pull that down here for a second. Now this is a little bit different because it looks at the result of logic operation coming into the CLK. I guess you could call that the clock line. And when that result of logic operation transitions from 0 to 1, Q turns on for one scan. So let me go and I'm going to put this back to normally open. Okay, and I lost my temporary bit. I'm going to use that same temporary bit over here. So by rights this should achieve the same result. But there's a slight difference here and I want to show you that. Save, download. I do kind of like the PTrick function a little bit better. And maybe you can already see why I would like that. We're still counting. Every time power on turns on, I get a one shot from Q. So the add block turns on for one scan and I count 1. Nice thing about using it this way is I'm not using any extra bits. I still have M0 or 10.0 as my temporary bit, but I can see the power on toggle on and off, which I couldn't see before when I was just using the symbol, the normally open symbol with a P in it. When I was using the normally open symbol with a P in it, I could not actually see power on, cycle on in this format. When I use PTrick, I can see the input turn on. Now typically you would use PTrick if you've got more than one condition on the input and you want to monitor a whole set of statuses as a result of logic operation on the input, but it also comes in handy just for the single bit that you're monitoring because you can watch that bit cycle. So it's kind of handy that way. Okay, one more way of doing this. Let me show you. I'm going to go offline. I'm going to go ahead and go down to PTrick. I'm going to pull this in here. Now something a little bit different comes up. Now this is an instance data block. I'm going to just leave the PTrick data block as its default. Say OK. I'm going to go ahead and get rid of PTrick because I don't need that anymore. But now something's a little bit different here because I have an enable rung or enable input and then the input I want to monitor, so this power is actually in the wrong spot. So it should be down here. And I'm going to go ahead and add, say, my reset switch here, just to show you something, demonstrate it. Okay, well, if you notice that the add block is now attached to ENO, which actually is the enable output, and that's not where we want it. Unfortunately, we cannot take this block and attach it right to the Q. We have to do something a little bit different. So I need to go ahead and add a contact here. I'm going to call it PTrickDB.Q. So that's the output of that one shot. I'm just going to move my add block down to this rung here. If it'll move for me. There it goes. Save. Download. I'm going to go back online. Okay, now nothing's happening. Well, in this case, nothing's happening because the enable input for the R trigger block is not enabled. And you notice my power on is not even being monitored in this case. So let me go ahead and flip that switch. So now I've enabled my rtrig block. Power on is toggling on and off. We can see that. And we can see my counter running as rtrigdb.q toggles for one scan as soon as power on is detected, changes from 0 to 1. Now, if you take a look at this block here, rtrigdb, and you look at it, this is actually a function block. If I was to go ahead over to System Blocks, open up System Blocks under Programming Resources, I'm going to see FB101. So their built-in function, rtrig, uses FB101, and FB101 in this case is using instance data block DB3. So it's no different than if I was creating my own FB. Every time I create an FB, I need an instance DB to go along with it. If I go ahead and open up DB3 and monitor DB3, I can see what's happening inside DB3. Not showing me a lot extra, but you could do that if you wanted to. Close that. Okay, so those are 3 different, in this case, rising edge trigger detection. I prefer the second one only because I can see whatever I'm monitoring toggle, and it gives me a better indication that that Oneshot is actually working. So let's say for kicks we just want to add a multiplication block. Again, I'm going to go offline. One of the reasons I do go offline when I do my editing, as soon as I go offline, I get my edit window back up over here where I can select from my logic bit operations, or the card window as they call it. So I'm going to use my multiply block, drag it down into the next rung. Now I guess I could theoretically drag it up and put it onto this rung at the same time. There's no reason I can't do that, except it will only work when this trigger is on. So that's one scan. If I want it to run every scan, then I need to put it on its own rung. So let's say we use our time count, and we're going to multiply it by 2. Now we need an output for it. So this is going to be double time count. Say double count. It's underlined in red. It's a little bit tough to see that because we haven't defined this yet. It's not on our symbol table. Now I can right click, say define tag. I'm going to define it as a global memory tag. Now you notice that it will tell me when I use it as a global tag that it will use the next address available, which is MD4. It's global data block, or sorry, global tag, global memory. Define, and there it is. Now the difference here is this add block will only run when this trigger is true. And that only occurs when this Oneshot triggers. The difference in how these blocks run, this add function will only run one time per one scan when rtrigdb.q turns on. And it only turns on for one scan after power on is detected going from 0 to 1. So basically every scan, this multiplication block will run. Since time count doesn't change, that's fine in this case. It's not going to create an iterative count like we had with this recursive add block. Download. Okay, I'm just going to turn my timer off for a second. Go to my watch table. It's already counted up to 4,469, so let's go ahead and reset this back to 0. Go back to control. Okay, now I've disabled the timer. Just go ahead and re-enable it. Okay, my timers are working again. Power on, toggling on and off. Counting to 5, 6, 7, 8, and multiplying it by 2. and delivering it to this data word. Now I could move this multiplication block onto the same rung. Let's do that. Let's try it. Come on. Monitor. See if that causes us any problems, and it doesn't, and I wouldn't have expected it to. Saves a little bit of scan time, only in that this rung gets executed one time for one scan every time power on cycles from 0 to 1. So it doesn't matter if this multiplication block is used every scan or just when this add block is triggered. Okay, I want to show you another thing here. Maybe you've heard of temporary words that can be used inside a program, and I want to demonstrate one way to not use those temporary words and talk about how to use them properly. Temporary words are used within the local function and only inside that function. They can't go outside the function unless you send it out through a global data word or a global word. So let's take this offline, and instead of using MD0, say we're, oh geez, we're using too many of these M data areas. We want to try to save some of the M words for something that's critical, because I don't need time count outside of this block. I only need double count. So I'm going to try to make this a temporary word. So temporary words, or start with pound. I'm going to call this temporary time. Now it's going to be red because it's not defined. Right click, define tag. I'm going to keep it as a local tag, double integer, say define. That's great. That means I can now call it up over here, pound temporary time. Now if I go to the top where it says block interface, I'm going to pull this down, and under temporary you'll see I've defined temporary time dint. If I take a look at my show all tags, you'll notice I do not have a temporary tag show up here because it's only for that one block. Close this again. Okay, to save, download, and monitor. And you're going, well, wait a second. It's staying at 0. What's happening here? Okay, what I didn't tell you is that these temporary words are initialized every time this block gets run. So if I go back up to this block interface, if I was to put a default value in here, say of 10 or 20, whenever this block runs, that default value will be put into temporary time and used as its default value until that temporary time word is changed. In this case, I don't have a default value, which means every time I run this block, it gets reset to 0. So I can't use it in this form. If I was to use it as an interim calculation, it would work, but not in this format. So I just wanted to show you that because it might be confusing. We have to jump out of the block and jump back into the block many, many times in order for the PLC to run. And every time we jump in and out of this block, this resets. So I just wanted to throw that out there. Okay, I put the block back the way it should be, and now I'm going to show you the proper way to use the temporary tag. Let's say the output from the multiplier double count is actually only needed temporarily. I only need it as an interim calculation. So I'm going to go offline here. Let's say I want to subtract something from that. So let's pull in subtract block, put it down here. So instead of double count, let's make this a temporary. Temp double. Now you notice my temporary time tag is still there because I haven't deleted it yet. But it just exists in the header. Define this tag, local, yes. So now I'm going to use this temporary tag here. And I want to subtract 10 from it. And now I'm going to take this to the outside world and call this double minus 10. Global memory. Okay, so now everything's defined. Save, download. Now we're looking at this going, well, wait a sec, it's not working. This is where you really need to understand what you're doing and how you're programming. Remember, this line here will only execute one scan every time power on changes from a 0 to 1. This will execute for one scan. It'll transfer the multiplied value into temporary double. Temporary double will be subtracted 10 and it'll populate into double minus 10. But the next time we come around and run this block, this bit will not be on anymore because it's only on for one scan. And remember, every time we run this block, the temporary tag temp double will reset to 0, which means now 0 gets entered into temporary double and see the result of that. So for one scan it would have had the correct value. For all the subsequent scans after that, it's reset back to 0. So this is a good example of how when you're programming you have to be very, very careful of how your PLC scans. If I go ahead and take my multiplication block and insert it into this rung, time count is a global variable, therefore it stays at its whatever state it's in all the time. It gets transferred to this block, which gets executed every scan, which means every scan temporary double gets not only reinitialized to 0 as we go into the block, but then time count times 2 gets put back into temporary double. Temporary double gets carried over to the subtract block, subtracts 10, and gets sent out on MD12. So now, save, download. Now everything's working. So I tried to show you a couple of ways of incorrectly using the temporary data areas and the way to correctly use the temporary data areas and why that happens. So be very, very careful again how you use one-shots, how they scan, how you're using your temporary variables if you're trying to save space, not eat up all your M words. And it's not always obvious why something doesn't work. You really have to think it through. So hopefully that helped understand how these blocks scan a little bit. It can get a little bit messy, especially when you're dealing with temporary variables or temporary data areas and a non-instance DB function. If I was using an instance function block, this wouldn't be so difficult because everything gets stored in the data block. But we'll talk about that another time.